8.2, graph simple rational functions. Rational functions are functions that have x in the denominator. That's our most basic rational function. We might have an x in the numerator, we might not. We're going to be using the idea of shift, and it's going to look really familiar. We use the same ideas of shift that we've been using. When we graphed exponential functions, you might remember we had a horizontal asymptote. When we graphed logarithmic functions, we had a vertical asymptote. It turns out that these guys have both. So side quest 1, we're going to look at the parent function for all rational functions. Y equals 1 over x. So let's start by making a table. You should be able to tell me what the one number is in the whole world that we cannot plug into this. Because what can we not divide by? 0. We can't plug in 0. Which what really means is at 0 we're going to have a vertical asymptote. We'll see that in a moment. We could plug in one number bigger though, and one number smaller. 1 divided by 1 is 1. 1 divided by -1 is -1. See what this starts to look like. Just like a log function, we have a vertical asymptote right at 0. If I plug in 1, we get 1. If we plug in -1, we get -1. What I want you to do right now is try to solve this equation. If I wanted to put in 0 for y, what would I have to put in for x? Think of a really big number like 1 over, if x was 5,000, 1 over 5,000. That's a tiny number. It's close to 0, but it's not 0. 1 over 5 billion. Still a tiny number, but not 0. Turns out we can't plug anything in for x to get 0. That gives us a horizontal asymptote. So we do get 2 asymptotes for these guys. Once we know where those asymptotes are, we can draw the curve with our other 2 points and be done with it. We still need to identify domain and range. These look a little different than we're used to also. Looks like we start at 0 and go on forever, either direction, but we don't actually include the point 0. If I try to plug in 0, I get nothing. So the way we say this is we say all real numbers except 0, or I'll even give you credit if you just say x cannot equal 0. Something similar happens for y. I notice I can go up forever, down forever, but I can never actually have y equal 0. And these 2 exclusions for the domain and range always match up with the shift. And we'll see a shift shortly. Concept summary, you always have a horizontal asymptote, a vertical asymptote, and then 2 pieces of the curve that don't touch. That's what rational functions look like. This key concept kind of tells you the same stuff. It tells you about the vertical asymptote, the horizontal asymptote, and what the curve looks like. So go ahead and pause the video and write down anything there that you think is important. And now we'll move on. So we're going to graph the function y equals 6 over x. That is a parent function because there's no shift. We'll see shift shortly. In fact, a little preview of that. Coming up later, we're going to see shift like that. So here the parent function would be -4 over x. That's getting ahead of myself. Here our parent function is 6 over x. So if we make our little chart, we know that we want to plug in some easy numbers like 1 and -1. We don't have a shift to apply, so our asymptotes are at y equals 0 and x equals 0. Now we can plug in our points. If x is 1, y is 6. If x is negative 1, y is negative 6. And that's really enough to draw our curve. And we will want the domain and the range. Because there is no shift, we just say x can't be 0, y can't be 0. We'll see what to say based on the shift in the next example. So let's talk about graphing and translation. The steps here aren't really the exact steps I'm going to use. I'm going to use that shift idea. But if you want to follow a different set of steps to graph those, you can follow these steps here. You can also look in the book and see how they do that next example. I'll be using the same ideas I've been using all along for shift. So let's take a look at this. I already showed this problem for a second. We see that it has a shift of, go ahead and try to think of the shift yourself. Pause the video and write down the shift. If you thought -2, -1, good job. That leaves us with a parent function of y equals -4 over x. So let's look at how we're going to make this chart. Still plug in my easy numbers like 1 and -1. -4 divided by 1, -4. -4 divided by -1, +4. Then we apply our shift. I need to shift all my x values down by 2. 1 minus 2, -1. -1 minus 2. Shift all my y values down by 1. -4 minus 1. 4 minus 1. And as I was explaining earlier, our asymptotes shift also. Instead of being at x equals 0, we're at x equals -2. Instead of being at y equals 0, we're at y equals -1. Beyond that, we plot our 2 points and sketch our curve. -1, -5. And I just caught myself in a mistake. If you caught the mistake, good job. My x's are supposed to shift down by 2. -1 minus 2 is not -2, -3. Sorry about that. The reason I caught my mistake is if I tried putting a dot at -2, it would be right on the asymptote. I know that can't happen. So I go to -3, +3, put my dot. Once you've got your 2 dots and your asymptotes, you can draw your curve. And we're done. At this point, go ahead and pause the video and try all of these on your own. No shift, 1 shift, 2 shifts. These ones are definitely harder. X on top makes it, or we actually can't see what our Y shift is at all. Our X shift we can still see, okay, it's going to be that +3. We have to make this look like the last problem. We don't want an X on top of the fraction. So we have to use long division. Hopefully you remember your long division a little bit. You can also use synthetic division. Let's see what happens if we use long division. X minus 3 on the bottom, 2x plus 1 on top. We ask ourselves, what do we multiply x by to get 2x? And the answer is 2. Now we distribute that 2. 2 times x is 2x. 2 times -3 is -6. Subtract 0 plus 7. So our remainder is 7. Remembering from back in that chapter where we did the long division, the way we would write this is 2x plus 1 over x minus 3 equals 2 plus our remainder over x minus 3. This looks a lot nicer for our purposes. Now I can see that my x shift is 3 and my y shift is 2. Beyond that, I can start graphing using my parent function y equals 7 over x. Make my table just like before. Plug in 1 and negative 1. 7 divided by 1, 7 divided by negative 1. Apply my shift. That shift says add 3 to all of my x values. 1 plus 3 is 4. Negative 1 plus 3 is 2. Add 2 to all my y values. 7 plus 2 is 9. Negative 7 plus 2 is negative 5. Then I can start my graph, putting my asymptotes in at x equals 3 because of my shift of 3, and y equals 2 because of my shift of 2. And then I can plot points. 4, 9. Way up here. I can draw that piece. 2, negative 5. And I can draw that piece. Once again, my domain is all real numbers except the x shift. My range is all real numbers except the y shift. So really the trick on this problem is using that division to rewrite the original problem. At this point, go ahead and try 4 through 6. You're going to have to use long division or synthetic division first on all 3. And that's it.